very first thing we'll do is we'll do import numpy as np. This np is an abbreviation. It depends on you, but the most general and widely used abbreviation is what numpy is np. Now I'll create an array, a variable called array1, and I'll do np dot array, and inside this I'll pass in a list 1 2 3 5, okay? And then I'll print array1. So this thing is a list. Looks like a list, but it is not a list. It is an array. Now this is a one-dimensional array. It contains only one list. So it's a one-dimensional array. How will a two-dimensional array look like? Like if you do array2 is equal to np dot array, I'll come to more specification and more details of one-dimensional and two-dimensional, and why we particularly need to use array, why vectors, why matrices is important in data analysis. We'll come to their importance later. For now, let's see how we can create a two-dimensional array. Now what I have done is inside the parenthesis, I'll add square brackets, and inside those square brackets, I'll add another square bracket. It's kind of a nested list, yeah, kind of a nested list that we are creating. So it will be 1 2 3 4. Let's say 1 2 3, and then I'll add a comma, enter another list 4 5 6. Okay, now this is a two-dimensional array. If you run this and print it, we get this. Now if I write array1 dot shape and array2 dot shape, before I move on explaining what are these outputs, let me tell you what shape does. Shape basically prints out the dimension of the array that we have created. Now, array in general can be n-dimensional. Like there can be more than more than one dimension. 3-dimensional array, 4-dimensional array, 5-dimensional array. It can happen. Well, now we are only dealing with one-dimensional arrays and two-dimensional arrays. The key difference between one-dimensional array is it's a list. We given a list inside np.arrays, and when we create a two-dimensional array, we given a nested list inside np.arrays. Now in numpy, if you are not using these nested lists, it will automatically assume that your input is a one-dimensional array. That's the rule. It just assumes that it's a one-dimensional array. So when it gives 5 comma nothing, it doesn't mean that there are 5 rows and 1 column or no column at all. It means that array1 is a one-dimensional array with 5 elements. Similarly, when we print array2 dot shape, gives out the dimension, and over here it treats this array as a two-dimensional arrays and give us rows and columns. So if we see there are 2 rows and 3 columns. Let's say we create an array3 and we write np.array and we put in a nested list, but we'll only pass one value inside a nested list. So it will be like 1 2 3 4 and 5. Same example. This time when I run array3 dot shape, what we get is 1 comma 5. So if you are creating a two-dimensional array, let's say a matrix of row 1 and 5 columns, so it's crucial that you use nested listing inside np.arrays when your intention is to create a matrix. If you want to create a one-dimensional array, just simply pass in a list value inside this. Now, bonus thing that I would like to say is these one-dimensional arrays are often known as vectors, and this two-dimensional array, that even if it has only one list like over here having one row and five columns, or over here having two rows and three columns, we call them matrices. Later on in this series, we will be learning about what how slicing works and different functions that we can use and it's beneficial for us during data analysis. Thank you.